This slideshow will cover hypothesis testing for a single proportion. The example we're going to use to work through this type of hypothesis test is an example related to misinformation on Facebook. A random sample of 850 American Facebook users were asked if they believe that social media companies should be legally required to protect their users from misinformation. 60.8% of respondents say they do believe this should be legally required. We want to know, do these data provide convincing evidence that the proportion of American Facebook users who believe this is different from 50%? We're going to start by setting our hypotheses. The null hypothesis, the status quo, is that the proportion of all American Facebook users who believe that this should be legally required, and we're giving that the notation P, is equal to 50%, 0.50. The alternative hypothesis that we're seeking evidence to support is that the proportion is different from 50%, or that P is not equal to 0.5. How will we find the p-value? Well, the p-value is the probability of observing our sample proportion, 0.608, or something farther from the null value, if the null hypothesis is true. Remember, the null value is 0.5, and we're giving that the notation p sub 0. So we need to know the sampling distribution of sample proportions, p hats, if the null hypothesis is true and p is equal to 0.5. So we'll start by checking conditions to make sure the sampling distribution of p hat is normal if the null hypothesis is true. The two conditions we need to check are independence and to make sure that the sample size is big enough. The independence sample condition is checked by making sure that we have a random sample, which we're told that we do, and that the sample size is less than 10% of the population. Here our sample size was 850 American Facebook users, and there are certainly more than 8,500 American Facebook users, so that condition is also met. The other thing we need to make sure is that the sample size is big enough. And the way that we check that is by taking n times p sub 0 and n times 1 minus p sub 0 and making sure that they're both at least 10. In our case, n is 850. If I multiply that by p sub 0, I get 425. And if I take 850 n and multiply it by 1 minus 0.5, I also, in this case, get 425. Since those are both at least 10, my sample size is big enough, and the sampling distribution of p hat should be approximately normal, with a mean at the null hypothesized value, 0.5, and with standard error given by the square root of 0.5 times 1 minus 0.5 divided by 850. Now, in order to evaluate if the observed sample mean is unusual for this hypothesized sampling distribution, we need to determine how many standard errors away from the null our sample statistic is, which is also called the test statistic. The test statistic looks like a z-score, and it's just telling us, remember, here's the formula for the standard error, and here's the null value. So it's telling me how far is my sample statistic, p hat, from the null value, and then figuring out how many standard errors that is. Let's calculate the test statistic for our Facebook misinformation example. So remember that our sample size n is 850. Our sample proportion, p hat, is 0.608, and our null value, p sub 0, is 0.5. Substituting those into our equation, we get 0.608 minus 0.5. And one thing to keep in mind is, in order to have the order of operations worked correctly, if you're typing things into your calculator, you're going to need to put parentheses around the numerator. Then divide that by the square root of 0.5 times 1 minus 0.5 divided by 850. This gives us the value of the test statistic of 6.30 if we round to 2 decimal places. So what this tells us is that our sample proportion is 6.30 standard errors away from the hypothesized value. Is this unusually far away? Yes, it definitely is. And we can quantify exactly how unusual it is using the p-value. Now we'll learn how to find the p-value using the test statistic. We're going to need to use the standard normal distribution with the test statistic to calculate the p-value. The p-value is going to be found by finding the area in the tails of the z-distribution that are at least as far from 0 as the test statistic. So in our example, let's find the p-value for our Facebook misinformation example. So remember, our test statistic had the value z equals 6.30. So what I'm going to be doing is I'm going to be starting by thinking about my alternative hypothesis. My alternative hypothesis, remember, is that p is different from 0.5. Since I have a not equal to sign here, I'm going to be doing a two-sided test. So the things that are going to be more standard errors away than my sample statistic was in either direction are going to be more supporting my alternative hypothesis. So if I think about this sort of stretching out, say, okay, my z value from my test statistic is 6.30. It's way out here. And my normal distribution, in reality, it keeps going out here. It's just getting closer and closer and closer to 0. Right? And there will be some tiny area out here under this curve beyond my test statistic. And likewise, if I come out this way, out below negative 6.30, there'll also be, getting closer and closer to 0, a very tiny area out here. So those two areas together are going to be my p-value. Now, since my normal distribution is symmetric around 0, I can find the p-value by finding just one of these areas. And so I can take twice the probability that my z distribution would have a value greater than 6.30. Now, if I use technology to find that probability, I get that my p-value is approximately 3 times 10 to the negative 10th power. If I were to look it up in my standard normal table, I'd get that it's, approximately 0. All right, so let's think at making a decision. We've said before that if the p-value is small, less than the significance level, then we will reject the null hypothesis. In this case, our p-value is 3 times 10 to the negative 10th power. If we're testing at any significance level, this is pretty much as small can get, almost. This is extremely strong evidence against the null hypothesis. Since this p-value is so low, we're going to reject the null hypothesis. So, making our conclusion, our p-value led us to reject the null hypothesis. The null hypothesis was that the proportion of all people who believe that social media companies should be legally required to protect their users from misinformation is equal to 0.5. The alternative was that it's different from 0.5. We've rejected the null in favor of the alternative. So the data provide convincing evidence that the proportion of American Facebook users who think social media companies should be required to protect their users from misinformation is different from 50%. Now, knowing that it's different from 50% isn't nearly as useful as if I can figure out which direction the difference is in. So once I've rejected the null hypothesis and concluded that there is a difference, I want to figure out what is the direction of the difference. And this is very easy to do because all I have to do is look back at my sample data. In my sample, the proportion who believed this was 0.608, 60.8% of people, which is more than 50%. So what that means is that that is the direction that the difference is in. There is very strong evidence that more than half of all American Facebook users think that social media companies should be legally required to protect their users from misinformation. So we'll finish this video with a real quick recap to how to test hypotheses about a single proportion. We start by setting up our hypotheses. Our null is always that p is equal to the null value. The alternative is that p is either less than, greater than, or not equal to the null value, depending on the research question. We check the assumptions and conditions to make sure that the p-hat sampling distribution is approximately normal. If the conditions are met, we calculate the z-test statistic and then calculate the p-value using that test statistic and the standard normal distribution. It's often helpful to draw a picture and shade in the area that is representing your p-value. Finally, once you have your p-value, you can make a decision and then interpret it in context. And remember, if the p-value is less than the significance level, we reject the null hypothesis and the data provide evidence supporting the alternative. If the p-value is greater than the significance level, we don't reject the null hypothesis and the data do not provide evidence supporting the alternative. Thanks, have a good day.